Ladies and gentlemen, welcome to Turn Right Machine Works. My name is Keith, and we're in here at the Clausing lathe. This is boat forks, part 3. All right, our jig is setting here, loosely bolted. Our part we brought up in here. In fact, yesterday afternoon, Eric came in just at the right time. I had it harnessed up. I have the hook from the gantry, and you can see. I'll just bring this on over. You can get, this is the picture, okay? You can see the top of that, I'm sure, from where you're at. But the top of that is 1/2 inch lower than the top of this gantry here. And, of course, this height and everything else. You have a little bit of interference because I'm trying to put this thing in here, and the beam is over here as well. So Eric was able to guide that while I put a blanket up here, and I was able to stand up on my ways and go ahead and bring this thing up, and we got the first clamp on it, and then from there we get 2 screw jacks underneath here, and we're ready to rock and roll. So I'm not trying to get a hernia. All right. Now, this setup is not a typical lathe setup. So we're going to be looking at our carriage top as the tabletop, like a mill tabletop. And the lathe spindle is going to remain a spindle, but it's going to be a spindle of boring, line boring. So we have to set this part up, set this bore up in line with this spindle. Okay, so what we're going to do is we're going to take our Starrett push button mag base, which is nice, small, slender base, and a nice, firm, skinny rod here. I like it. And we're going to stand it up like that, and then I think we're just going to bend the end over here because we want that face to be facing so we can stare in the bore. And then we can read this thing 360 with no mirrors or anything else in that fashion. As long as we may have to adjust that rotation because of where it's at in relationship to this magnet here. All right. Now we can stand this thing on the end. See if I can get it in here and connect it to the end of my shaft right here. And I'm just kind of sliding it around, making sure that it looks good. I think that looks pretty good. Okay, now we have it in there, and I think it'll sweep with clearance all the way around. Okay, good. We got it in a good position there. Okay. Now let's see. And that shows that we have about 80 thousandths that we have to drop it down. Because I think that's about 160 difference there. We're gonna go ahead and we're gonna try to bring this thing horizontal first. We have a little bit of side to side, and that's evident right there, but that's just twisting our plate. That's not too bad. And then out here you can see that we are only about 55 or so on the low side. Okay, I set that dial at 0, pointing against the top of the bore. We're just going to call it the top because it's facing up right now. If this was turned around, it'd be the bottom, right? Okay. All right, the top of the bore. And now we're going to rotate it around to the bottom of the bore. And you can see that we're real close to 150 thousandths off. So we got to go down at least 75 thousandths, something like that. So what I'm going to do is I'm going to loosen on the screw jack on this side. And of course I'm going to go very slightly, because somehow I think the clamps are going to hold it as I go down. Yep. Alright, well, this is, it's not moving right now. I'm gonna go ahead and take my calipers here and 1 inch 945, so I'm gonna have to come down 75 thousandths. Just a skosh more. Okay, looks like we got there. If not, just a little bit more. All right, screw jack is back underneath here. Now we're gonna take our rawhide mallet and we're gonna tap it in the direction towards the headstock. Okay, last tap sounded solid. It's not solid there. That rear one's solid. Okay, now that one's solid. Alright, let's check our indicator. Of course, you've been looking at it, not me. Bring it back to the top here. And we'll set that back. Close enough to 0. Okay, and we're coming up to pretty close to 0 again. Down there, we're actually minus 12 or so, and we can adjust that. Okay, let's swing this back around to our 0 up on the top here. Okay, now I'm just going to run the lathe bed down to this end. You know, I want to get it close up and down, but also in alignment. Now we're reading the top of this because this is the non-stressed area. If anything was bent, distorted, or whatever because these forks were hanging, it'll be on this low, thin side here. This side here would be free and from any defect. So that's why we're going to go ahead and we're going to dial. This is going to be 0 across this top right here when we get done setting this up. And then side to side and will be average between both sides. And whatever this bottom is where the bottom is going to be when we go to skim it. Okay, if we sweep 0 across from 9 o'clock to 12 to 3 o'clock, then we know that this side of the bore is perfectly fine and this side of the bore is just disrupted. So, and there's controversy whether this weld out here did anything, and if that weld was pulling, it would be shrinking in on that side, and it would elongate somewhat. Some feel it the other way around, that it would be pulling, but it'll contract, and contract on the bore, and that would bring this wall in over here on this side. Same thing on this side over here. But we're going to dial this, and then the bore will tell us what actually happened, and more than likely it was the material is stretched because of an overload. All right, so we got 50 thousandths there, and we know the other side was minus 12. All right, now if we took this and we went 50 here and we went around to here, it's almost, there's your 9 in there. Okay, so we'll crank this up. $50 thousandths. Just for curiosity, let's go ahead and make that 0. and we're about a minus 10 there. All right. Now let's bring it back to the top. Let's roll the carriage back towards us. Minus 5. And we had minus 12 there before, and almost look like minus 5 now. Okay, let's set this dial at 0 now. Roughly in the bore. Okay, we're against the back side of the wall on the spindle side, the chuck side of the part, and we're going to go ahead and we're going to crank her back. All right, so we're going minus, almost minus 50. So that's just telling us that this part here is that way 50 thousandths more than the other side in relationship to that wall right there. Now we spin this around, and from minus 50 we come back to only minus 15. Now we're going to crank her down this way here till we get back down to the other end, and we're almost minus 60. What that's telling us is we've got to move the whole part towards the back of the lathe, but we got to take a little bit of a twist, so we got to turn this side just a little bit stronger than the other side there, and that's what we're going to do. And we're gonna do that by our bolts for holding down to the table are loose. We're going to lightly snug them, and then we're going to start taking our rawhide mallet, and we're going to be tapping the angle bracket itself to manipulate it into position, and we'll come back to the reading there so that I can concentrate on where I need to go, and I'll bring you back in when we've got it side to side lined up. All right, we came over here and we lightly tapped it, and we set 0. We came across the top. Now you can see the top is only like minus 7, so we just need to come down just slightly, and over here is about plus 1 or so. And we're not going to nitpick it too close, but I'll just show you that I can tap it back and forth that way. All right, we only have one bolt snug right now, one T-nut slug held down solid. Okay, so now let's come over here and let's come back across that back side. Crank it all the way to the other side there, and it looks like we're like a positive 42 or something there. All right, now instead of tapping on this, I have a nice little groove in the carriage cross slide right here, and a nice heel bar, and I'm just going to reach in between that crack there, and I'm going to gently twist this thing back to 0 right here. Okay, now let's run the carriage back down, and let's see where we're at. Okay, about half of it, or is it 15 and minus 15. Okay, now we're going to go ahead. The bolt I'm tightening down is 3 inches in from where I'm reading, and the offset of where 0 is magnified just slightly. But we're just going to go ahead and loosen this slightly, and that's minus. Bring it back to our 0. We didn't change it, so it should maintain 0 side to side. Okay, Now let's bring it back down here. Okay, and we're within a couple. Let's take our heel bar and do the same thing. All right. And that's on the plus side right there, which means another light tap there. Swing it around. Okay, we're within 1/1000ths right there. All right, now let's swing it around down at this side. And of course, I'm gonna bring it all the way down here because I'm over here. I can see the edge now, and I'm just sticking my mirror in here so I can see. It looks like -2. Okay, I'm playing with little battery life there. So we were sweeping from this side here, which we had pretty close to 1, right? Okay, let me just adjust it again here. Okay, close enough for 0 for what we're going to show. We have 0 there, and then we're going to sweep it. We got minus 10 there, and we got within 1/1000ths against this side here. And then we have like -9. Okay, so we're almost on the money side to side, and we're equally up and down, and that's -9 to -9, which means the up and down is 20/1000ths. That's what we were measuring in on our measurements, was 20/1000ths on this one, 30/1000ths on the other one. Okay, so I think what we need to do, we're going to go check the other side now, but what we need to do is make a decision on lowering the thing 10,000, sweeping it around, and having that completely taken on the other side. There's -10 there. There's pretty close to 0 there. There's -5 there, and 0 there. So we're a little less out around on this side here, but we're almost duplicating it. All right, and just within a couple movements, we've got this thing almost dialed in. A lot of people ask about the tooling and the tooling costs for the customer, and you have to have tooling costs. Now, I build things so that I can use it for other things, and so I usually don't charge for material, but I do charge for my labor to make the tooling itself. And I try to be as fair as possible to the customer in doing it. But you can't do the job without making tooling sometimes, and it is part of the job. Just period. That's the way it is. All right. Now, I only have this bolt here tightened, and I'm going to lightly snug this one and go around, all the way around. Alright, and we're going to lightly snug these up. Not real tight yet, just snugging it up. That way we take and we get it all situated down and flat. We've taken compression out of our setup. Just like engine alignments, beds, and all of that, you get it down close, and then you got to cinch those down so you can take up any idiosyncrasies of twist and pull and shims and all of those. Pump alignments, the same thing. So you kind of just snug it all down, and now we'll go ahead and rotate it and see what we got. We're actually -2 on the top there, and -3 over there. Or excuse me, that was +3. -3 there. 0. See, so it moved just slightly. But we're still real close in the ballpark, and I'm sure that I'll be able to tap it a little bit to get it that last thou or two side to side, and we're going to adjust up and down, I think, just to take half of that distance out. Okay, I think we're pretty well set, except for maybe adding some more clamps, but I think this is going to be our last and final readout here, and then I'll put on the clamps, and if it stays the same, then we'll start setting up the bar. Alright, top dead center, we're at 0. We go over this side here, and we fluctuate no less than 1/1000. Same thing over here, about 1/1000. Alright, from this point here, around to the bottom, you watch. It takes off, goes down, there's your 20,000ths, comes back up to there. Okay, so the dip is all in that section right there. That's telling us that that was stretched. Alright, this stays too uniform between 9 o'clock and 3 o'clock. Alright, now we know that the top is the sane part, or the sane area to measure for our run out. So we're going to dial from here to the other side on the top. Alright, let me look and verify. We're hung to 0, within 0.5 That's fine. Alright. I'm going to do that again because I want the light on the indicator. Okay, we're going to travel along until we get to the other side. There we go. Where are we at? We're within 1/1000 there. Now the same thing here. Over to 3 o'clock there. Couple thousandths. Come over here. Couple thousandths. Well, it was a couple thousand. Now it's 0. We'll take better. All right. All right. Now, from there down and around, you can see that we got 25,000ths there, and then back on up to our couple that are there. Same thing. It shows you that this side actually is stretched more than the other side by 5,000ths. But from there around to here is almost perfect, within 1 thou or 2. All right, we have aligned this part to bore it. By having the solid material up at the top and the clearance down at the bottom, we're going to increase our bore size so that it'll only take the material off of the solid section, or the non-working, the non-load-bearing side. We're going to keep as much material on the load-bearing side as we possibly can. Okay, after my final tightening, I went ahead and swept the indicator there. I took a little break, and I got to thinking that the most important material is not right here at the very outside, but it's what's here and what's here on both sides. And if I truly made it to where I would take everything out of this side here and barely touching here, I would end up taking more off of each side than splitting the difference up and down and only taking the difference of the egg shape. Okay, so I made an adjustment, and I jacked it up 10,000ths so that I'm going to have, when I first come, I should be touching the sides and not the up and down to when we go to get our touch off. But right now, let's go ahead and get the bar slid in place and get it indicated, and we'll be ready to rock and roll here. All right, 1 and 4 jaws. I always kind of pay attention which jaws I bring out. All right, I got the carriage up as far as I want to go that way. So what I'm looking for on this side here, this is my bit hole here, and I want to be able to come out past here quite a bit. If I have to pull the bit from this side or adjust it from this side, I want to be able to do that, because this hole is set up to where I can bore either direction. I do have it more offset to run in the right hand direction, meaning clockwise from the other side. right, bring this in here, and I can choke this way down. They choke everything down as much as you can so the setup is more rigid. One of the most difficult things sometimes is to take just a little bit. Sometimes you can't just take a little bit. You gotta take a hog cut. And all right, now I get my indicator on here. Look at that. I'm gonna actually use my Noga. If your axis is spinning between that center and here, no matter how much run out this bar has, when you set your cutter, it'll still sweep a circle. Okay, so I'm just doing this so I don't have to look at a bar going up and down. Just kind of food for thought as far as how true your bar's got to be. All right, we go around. We make sure that we're tight all the way around in here. We have our aluminum covers on our jaws here so that we're not digging into our shaft. I like that. Retension the center. Double check it. And yeah, it's running 2000s now. Oh. Well, you double check it. Okay, I like that. Ready to go.